grid below. So we're going to use these as our ordered pairs. So we're going to have 0, 10,000, 1, 20,000, and so on. Right? So this is my x, and this is going to be my y value. Okay? So go ahead and do that. Go ahead and graph those. Does that increment seem weird to you guys? We're going by 40s, right?
You went from 160 to 300. Yeah.
Well, that's not good. Okay, I was like, what is happening here? All right. That's more like it. So your graph should look somewhat like mine. It's kind of hard down here to do the 10,000, 20,000. So I know they kind of look like they're both at about 20, but I tried to kind of show a little bit of a difference there. And then it shoots up here after another, every decade, the difference is greater than it was, right? So it's clearly nonlinear. Why is it nonlinear?
It's not a straight line.
It's not a straight line, but what if we're looking at the table? How would we know it's not a nonlinear? What do you need to have in order for information to be considered nonlinear? Or excuse me, to be linear? You can write it in slope-intercept form, which means it has a, how do we find the slope? It's a constant rate of change, right? So our table does not have a constant rate of change. Our graph is clearly not a straight line. Right? It very obviously curves up. And that is the perfect example of exponential growth, where these start separating out further and further, and the line just shoots up. Right? Eventually, it's going to look like it's a vertical line. Right? Okay, go ahead and answer 8 and 9. While you're answering those, I'm going to put the information here so you don't have to keep flipping your paper back and forth. So I will freeze this so you can just look at questions 8 and 9 and then use this table to help you. I mean, it could be both. I mean, your prediction is going to be based on what you think it should be, right? So, I mean, there is a pattern that's happening. Okay, so what did you come up with for your prediction? What did you come up with, Eden? Great. How did you know that? Yeah. You multiplied the 320,000 times 2 because that was what the real estate association said would probably happen, right? What?
So I was like really confused because I forgot it was going in decades. So I was going by like each individual year that it was going up, like doubling.
Oh yeah, no, that's a really expensive house.
Yeah, so
It was like 5 to 10 million, like 2015.
Is that what you were doing too?
Yeah.
Oh, you guys. How many people made that same mistake? Really? Wow, that's surprising. But so yeah, all you had to do was double 320,000, right? And so what do you think the price would be in 2005? What did you have for that? Avery?
240,000.
How did you get 240,000?
Because it was at 2000, it was 160,000, and because 5 years is half a decade, I divided 160 by 2, and then added it to 160.
Yep. So you just took, if it doubles in 10 years, take half of that double, then add it to find the 5-year value, right? Okay. How are we feeling so far about exponential growth?
Good.
Seems all right. Hey, Vince, how was your birthday?
Good.
How was your dinner?
Better.
Yeah? What did you get? I mean, I know where you went, but what did you have while you were there?
Just a normal cheese pizza.
Cheese pizza. Do you like extra cheese on it? Have you guys ever ordered a pizza with extra cheese? It's life-changing. But once you have it with extra cheese, you can never have it normal again, so I caution you to make that choice. What else did you have?
I'm a much of a cake person, so we got crumble cookies after it.
Caramel cookies were, it's right there, basically, because you were at Clay Terrace, is that right?
Yeah.
Very nice. Okay, glad we caught it. Did you get any fun gifts?
I'm doing a room remodel, so I'm not really getting
Okay.
other gifts because it's pretty expensive.
It is pretty expensive. Right. How are you remodeling? Is it your bedroom?
Yeah.
What kind of things go into a bedroom remodel? Because I can just picture like 4 walls, so I'm not sure.
Well, I'm repainting and getting a new bed and a new desk and stuff.
I mean, that's a remodel. Are you getting it from IKEA? I love IKEA. Are you really? IKEA's pretty cool. Anybody else have IKEA furniture? It's a pain to put together, but then it's like really cool once you do it.
Your dad seems like an IQ.
What color are you painting your room?
Some shade gray. I don't know.
I would highly recommend a color called Perfect Grayish. Have you heard of it?
Oh, could your dad bring it to
My boys' bedrooms are perfect grayish.
So the gray,
It's like a gray beige. It's perfect. Like a brownish color, so you mix them together, but it looks better than it sounds.
brown and green.
Perfect grayish. Vince, did you write it down? Perfect grayish. Do you need me to write it down for you?
What's the second word?
I'm going to write it down for you. I'll put it on a post-it for you. And you know what? I'll even look it up on the Sherwin-Williams website and get you the numbers.
You should just write down for a second. Yeah. And spend like.
We'll do it at the end. We'll do it at the end.
Yeah.
You distractors. Okay. What are you talking about? Yeah, right? I like that you guys think I don't know that you're trying to distract me.
I asked the last
I'm just really curious about paint colors.
I know you are, Jackson.
It's my, what's your guys'?
It's your passion?
Yeah.
Is that your
I
passion?
have a paint fetish.
Paint colors are your passion. Okay, let's keep talking about Tony's grandparents' house. This increase is an example of exponential growth. Exponential growth can be modeled by using an exponential function of the form f of x, don't let that scare you, that's just like saying y, equals a times b to the x power. X is the domain value. F of x is the range value, y. A is the initial value, and b is the constant ratio. In order for the function to be exponential, the values of a and b have the following restrictions. A cannot be 0, b has to be greater than 0, and b cannot be 1. So we'll practice where you guys will be like, wait, I can't do that. It'll make more sense. Okay, the value of Tony's grandparents' house is growing exponentially because it is multiplied by a constant factor for each decade. What is this constant factor?
2.
2. Yep.
How did you know that?
It was the ratio, right? 2 to 1. Also, it doubles. Okay. Write a function in the form listed above, item 10, that can be used to model the value of Tony's grandparents' house. So we have f of x. Remember, that's just our fancy way of saying y.
Can we just put y, or do we have to put f of x?
You need to write f of x. Yep. And they told us that x is the domain value, f of x is the range, a is the initial. So what was the initial value of the house? $10,000 times the constant ratio, 2. And then this number here is, it's kind of hard to explain, but it's like, how many decades do we want to know ahead of time? Does that make sense? So like, if we want to know 3 decades from 1960, we would put a 3 there. If we want to know 4, we would put a 4, right? So the x here is the decades since 1960. So let's label this 2. This is our initial value. And this is our factor. Well, we'll write constant factor. We'll stay with the same vocabulary. Okay. So I'm going to try it out here. See if this works. Make sure we got this right. So if I wanted to know 1 decade since 1960, so if I wanted to know the price of the house in 1970, I would do 10,000 times, or first I would do 2 to the first power times 10,000. And I got 20,000. So that works. If I wanted to know the price in 1980, what's my number going to be here?
2.
So this is where you have to do the exponent first. Can you guys even see this? So I'm going to do 2. I choose this x to the y to the second power times 10,000, and I get 40,000. I know the lighting is really bad in here.
Why can't you do 10,000?
Because you do parentheses and exponent.
Does that work with penny too?
It does, but you could do parentheses and exponents, but if you just take care of the exponent first, it makes it less potential for error. So if I wanted to know the price, we said in 2020, we thought that the price would be $640,000. How many decades is it after 1960 to get to 2020? 6. So 2 to the 6th power times 10,000, and I get 640,000. What if they told us that the value was tripling every 10 years? How would that change this function? Yes. Does the x value, this little x value change?
No.
Does this number change?
No.
No. Does the value of the house change drastically?
I mean, it depends on the year.
Tripling a number is, yeah, that's going to be a big change. But you're right. Further years. Okay, so it just asked us to identify the meanings of a and b from our function. So obviously this is a equals initial. home value. Right? B equals the constant factor. Oh, we just did number 13, didn't we? We're just going to write yes. It matched because we smarties. Right, Cece? Do you have a plan this weekend? You got anything going on? No. No sports?
No.
Just hanging out? What do you have?
Are you doing that game? Oh yeah, I might go to semi-state.
Oh, are you going to go watch in Logansport?
Yeah, I might.
I think you should definitely go. They are a really good team to watch. They're really fun to watch. Anybody else have plans?
We should go look at the paint now. Please.
You want to watch paint dry?
Yes,
Yes.
I'd rather do that.
Watch Blue. No.
It's not episode.
Listen, we just have a couple more things to do. If we were going to calculate
Eddie, do you feel no
the year 2005,
when the grandma finally said,
if we want to check our work about the price of the home in 2005, what's my exponent going to be?
What?
It is going to be something and a half.
4.5.
It's going to be 4.5. Why 4.5? It's between the 4th and 5th decade. So let's see if that works. I'll get out my fancy calculator here. 2. I have to hit x to the y, 4.5. That's ugly. Times 10,000.
What did they do wrong?
I don't know.
Was this supposed to work?
It was. I mean,
It's the 0.5.
lower. So the way it compares is that it's definitely lower.
That's probably just the price.
The only way I can explain that is maybe it's because the in-between values are a little bit less reliable than than every 10 years. But I mean, it all has to. There's so many factors that go into real estate. It's bonkers, right? How is it? You know what? We're gonna stop. Yeah, there's someone at my front door. That's all. We're gonna stop there. I don't want to get into this next thing. No, you don't get to play silent ball until I show you perfect grades.
Are you kidding?
What?